This is a demo of DNS exfiltration. I'll show you how it works and how to detect it with UberAgent and Splunk. Let's take a look at this dashboard. It's designed to show you risky DNS activity. Currently, it's empty. That's good, because there hasn't been any risky activity. So let's create some. In this window, we have PowerShell running on a corporate laptop. We've prepared a little script that reads the documents in the current directory, splits them into little chunks, and transfers those chunks via DNS to a target machine. This target machine is a Linux machine on the internet that's running the DNSTL script, which accepts the data being sent to it via DNS and writes it on disk. So let's start the fun. This is going to run for a few seconds here on the left-hand side. You can already observe the individual DNS requests originating on the left-hand side from the corporate machine running PowerShell and being processed and saved to disk on the right-hand side on the Linux machine on the internet. And we are done already. So let's stop the DNS server and take a quick look at what we got. We have two files, a password.x file and a password.txt file. So let's take a look at one of them. And wow, this looks good. Apparently, this worked like a charm. Now let's head back to that Splunk dashboard and take a look at how what the detection looks like. So you remember this chart DNS risk over time, it was empty. Now it's not anymore. It shows us there has been a lot of activity by PowerShell.exe. Let's click it, drill down, and take a look at what exactly happened. So we see here there's been a lot of DNS activity. We can see the individual requests. We can see the encoded data. We can see the file name where the data originated from. And here in this columns, we can see why UberAgent detected this activity as risky. In this case, it was risky because of the length of those DNS requests. Okay, so let's move up a little bit and take a look at a different way to detect DNS exfiltration. In this case, the dashboard also has a histogram that shows you unusually large DNS requests. So you can see regular DNS activity in our test environment here has around 20 bytes, a little bit more than 10 bytes, sometimes nearly 30 bytes, but that's typically it. DNS packets only transport the actual DNS name and the response from the DNS server. So they're not typically not very long. But if we move way over to the right-hand side, we see we have a lot of DNS packets, more than 400 of them, with the maximum allowed length of 250 bytes. So that is very suspicious. And again, we can drill down and we'll see the same have the same insight into the actual DNS requests being made from which host, which application, which process on that host, and what exactly was being transferred. Thank you very much.